Hello students, welcome back. Previously, in the first video, we went through a review of polynomial expressions within the elementary algebra level. That is, we went through the basic definition and some terminologies, and then some elementary examples, really trivially simple examples. We didn't do anything fancy. Now, let's go to intermediate algebra level and let's do the division algorithm. This is a review too, but there may be more students who are a little bit hazy about this than the previous video, so I divided. Alright. Let's suppose we have a couple of polynomials, f of x and g of x, and let's divide f by g. We're going to call f and g by dividend and divisor respectively. So f is dividend, g is divisor. Then f can be written as q times g plus r, where q is the quotient and r is the remainder. Or equivalently, from here divide each by g of x. Then you're going to get f over g is equal to, now divide g away, so that's gone, so you just have q, and then r over g. So this expression down here and that expression up there, those two are equivalent. So from here divide by g, we get that. From here multiply by g, we get that. And these two expressions are analogous to these two expressions here and there for real number arithmetic. Excuse me, did I say real number arithmetic? No. Positive integer arithmetic. So 48 divided by 5, that's something we are calculating. So we are doing, basically we are doing 48 divided by 5 in the positive integer arithmetic. That's basically what we are doing. All right. So 48 can be written as 9 times 5 plus 3. 9 is a quotient. 3 is a remainder. Or equivalently speaking, 48 divided by 5 is integer part 9 plus 3/5. And here, please note, the remainder 3 is less than the divisor 5. This is important. If the remainder is same or more, then I can further divide. For example, if I rewrite this, 7 and then like this. This equality here is absolutely right. But this is not a division algorithm. This is not a quotient. This is not a remainder because 13 is greater than 5, so I can still divide by 5 and then reduce it further. And then you're going to get additional quotient of 2, which will be added over here. And then after that, I just get 3. So this kind of thing is the division algorithm or division arithmetic in positive integers. And something similar is going on for polynomials. We cannot compare polynomials directly, so we compare the degrees. Okay, so much for theory. I think I spent a bit too much time in theory. Let's go to concrete problems here. We have these two problems. Now, if you're already comfortable, or at least to a certain degree you remember, then stop the playback here and try on your own first. Otherwise, let's begin. F and g are like these, and let's do the division. F of x divided by g of x. Basically, what you want to find are the quotient and the remainder. Okay? All right. So basically what we want is, these kind of expressions. Okay? So we're going to find out what is q and what is r. Okay, how do we do it? This kind of technique is called a long division, And this kind of long division is analogous, not exactly same, but analogous to the long division for positive integer arithmetic. So we have the dividend here, and then the divisor to the left. Okay, f of x is here, g of x is there. So I no longer need that problem set. Okay, step 1 is to focus upon the leading terms. The leading term 3x cubed is equal to this leading term x squared times something. What is that? Of course 3x. X squared times 3x is 3x cubed. Alright? Now that this 3x is settled, multiply this 3x to the entire divisor, not just to the leading term, but to the entire polynomial. The result is 3x cubed plus 3x. Make sure you write 3x in the right column. You have to align properly. 3x and x are like terms. 3x and 4x squared, they're not like terms, so they don't mix. It goes to this x. Alright. So where are we? We have dividend and divisor. Focus upon the leading terms. 3x cubed is x squared times something, and that's how you got 3x. Alright, now that I got 3x, multiply, we get this, and then subtract. So, subtract 3x cubed minus 3x cubed, that's gone, that's the idea. 4x squared, nothing here, so minus 0, so 4x squared. X minus 3x is negative 2x, and 7 minus 0 is 7, so we get quadratic polynomial here. Alright? And then we continue the same thing. Focus upon the leading term. 4x squared is x squared times something. So what is that something? Of course it's 4. So multiply by 4 and subtract. Let's go back. Dividend here, divisor there. Step 1, leading term, and get a first term here. Next, multiply and then subtract. Okay, now focus upon the next leading term. Get the term here, monomial here, multiply and subtract. And then get the leading term, multiply and subtract. And then get the leading term, multiply and subtract. Repeat this until you cannot do this any longer. Here, I have negative 2x plus 3, and this degree is less than that of the divisor. So this leading term, negative 2x, cannot be written as x squared times something. X squared times the smallest possible one, 1, is already x squared. This is degree 1, so you can't do it anymore. So the process stops, and that's the remainder, and there goes the quotient. You can write like this. The divisor here is equal to quotient times divisor. Excuse me, the dividend here is a quotient times divisor plus remainder. Or, in terms of fraction, dividend over divisor is quotient plus the proper fraction, remainder over divisor. Makes sense? Everything is in the same viewing window here. Stop the playback and review a little bit. Okay, let's go ahead to the next problem here. Stop the playback and try on your own. Have you? Okay, let's go ahead. This is a dividend, and that's a divisor, alright. So how do you do it? Dividend and divisor. And when you write the dividend, make sure you have proper space for this x squared because you're going to need it. As a matter of fact, fourth power, third power, you don't have second power here. So 0x squared is there, and putting 0x squared there is actually a good idea. I usually do it that way. I don't put blank and skip. This is a textbook's method. Me, I put 0x squared here. And then just calculate with all those zeros. That's the way I usually do it. In the previous problem, I rewrite this one as 0x plus 1 like this too. Okay, let's see, how does it work? Look at the leading term, x to the fourth power. That's equal to this leading term times something. So that something is x squared. That's easy. So from the leading term, we get this, the first term of the quotient, and then multiply and subtract. Multiply and subtract. Multiply and subtract until you get to the remainder that you cannot do any longer. In this kind of problem here, make sure you are doing the subtraction correctly. Previously, we had only additions here, all positives, so we don't have a lot of sign changes, but here, a lot of negatives are flying around, so it can cause confusion. For example, here, negative 3x cubed minus of negative 3x cubed, so we have negative 2x cubed. That can be confusing, man. Here, negative x squared minus of positive 2x squared, so negative 3x squared, and so on and so forth. It can be confusing, so be careful about that. Otherwise, you can handle it okay. As for polynomial division, what can I say? There are so many computations here, so many tedious computations, and there's so many possibilities of making silly mistakes and almost impossible to get it back. Therefore, this kind of problems are really pain in the rear end for a lot of students. So let me give you some mathematical commands to work you out. So here, the term is polynomial quotient, and I'm dividing this polynomial by this polynomial. And then with respect to the variable x. And that's a quotient. Copy and paste that. Polynomial remainder. We get that. Now, how do we use it? Let me give you a nice website here. wolframalpha.com, which gives you the free web-based version of Mathematica. And then, okay, I don't save time, so let me just copy and paste this thing to this. And if you have enough time, you have to just type it in and then let it run. And then it did a computation, and then it found out the quotient. wolframalpha.com again. And then this is for polynomial quotient. Okay. Copy and paste the command here. Dividend divided by divisor, and x is the character, the main variable. And polynomial remainder is another term, another command, and that'll give you the remainder. That's the remainder. So it's going to be a good idea to check your answer using computer algebra system. And polynomial quotient and polynomial remainder are two very useful mathematical commands that you can use. I'll conclude section 0 here.